All right, so we're ready to begin talking about the two tissue types, two tissue layers that we see in the integumentary system there at the cutaneous membrane. The epidermis, which is the most superficial layer, and the dermis, which is the deeper layer. And we'll start by talking about the characteristics of skin in different parts of the body. Because in some parts of the body we find what we talk about as thick skin, and in other parts, thin skin. Thick skin is up to about 0.5 millimeter thick. And where would you imagine the thickest skin to be? Likely you would have thought of the palms and certainly the soles of the feet. And characteristic of thick skin is that there are 5 distinct cell layers in the epidermal layers of the skin. So we'll take a look at those 5 distinct cell layers in a minute, but you can see them here. If this is here we have the basement membrane separating the dermis below and the epidermis above, and then as you look from this layer here at the bottom toward the top, you can tell that the cells change. And so the cells are named at different levels of the skin based on the characteristics of those cells. Thick skin, if you look at your palms and your soles, you would see that it's hairless and lots of sweat glands there, as anybody who's ever gotten nervous probably remembers. So thin skin, on the other hand, only 4 distinct cell layers, and it is much thinner, about 8/100ths of a millimeter thick. And it has hair on it, so everywhere on thin skin we see hairs. It may be very sparse in some areas, and it may be heavier in others. So if you were to look, say, at the posterior surface of your arms, they tend to be hairier than the anterior surface of your arms. And remember, you got to hold your arms in anatomical position to distinguish between anterior and posterior. So there's hair on thin skin, and we find oil glands and sweat glands. It would be very unfortunate if we had lots of oil glands on our hands or our feet, because we wouldn't be able to grip things, and it would be harder to keep standing on slick surfaces if we produce lots of oil. So here's a microscopic view of some thin skin. Here is a melanocyte down there at the bottom layer. And again, the cells look different as we work our way from the deepest layers and get toward the more superficial layers. And once again, they're named based on characteristics of the cells at each of those layers. Okay, so let's take a look at the changes that we see in the keratinocytes as the cells mature and get closer and closer to the apical surface here of that epidermal tissue. So if we were to look from the bottom upward, the very deepest layer is the stratum Visalli, and we're going to talk a little bit more. I've got a slide for each one of these strata, but the deepest layer is the stratum Visalli, and that's a term that I suspect has been borrowed from geology. If you ever drive like up, along a mountain road where they've made cuts into the mountain, and look out the windows at the rock, you may notice that the rock comes in layers. Each one of those layers, they're referred to as strata, the plural of stratum. And so it's the same in skin. We see different layers and different characteristics at different layers, and so they're referred to as stratum here. So stratum Visalli, base, should be what you're thinking about when you see that term Visalli. This is the deepest layer, and it's attached to the basement membrane that is secreted primarily by the fibrocytes of the dermal layers of the skin. As you head superficial, you come to a layer that, everything that is the second cell up from the bottom and above, that's the stratum spinosum, the spiny cells. And I'm not sure why. I've seen them up close, and they don't look particularly spiny to me, but that's the term that's given those layers of cells, and there are a fair number in the stratum spinosum. Toward the next layer up, this would be this dark layer here, is referred to as the stratum granulosum. The stratum granulosum have lots and lots of granules of melanin in them, and that's where they get that name from. And then there's a layer that is just a couple of cells thick, but it's translucent, and so it's termed the stratum lucidum. And, oh gosh, I'm looking at that, and I'm thinking, yep, I misspelled that. I apologize. So let's have a quick correction here. That's stratum lucidum. So that I is incorrect. It should be a U. So there's the stratum lucidum, and that's a layer that's found in thick skin only. Now, it's not the reason that thick skin is termed thick skin. It doesn't give the thickness because it's just a couple of cell layers thick. But we only see this stratum lucidum layer in thick skin. And then finally we get to the most superficial layer, the stratum corneum. Corn means horn, and so these cells, and actually if you look at like a rhinoceros horn or a cow's horn, they're built of epithelial tissues that are stuffed full of keratin. So there's a characteristic there that is shared, and so this is the horny layer, or the it's the toughest layer, and so we'll talk about in a minute about the characteristics that give it that toughness. Okay, so we'll start by looking at the stratum Visalli, and I've already got a lot of this printed in your notes, so you may want to take your own notes from it, or what I say, and then compare them to what I've got printed, or you can go with what I've got printed. So here at the stratum Visalli, this is the deepest layer, and these cells are attached to the basement membrane. So the basement membrane gives them good support. And these are cuboidal cells attached right down here. They've got roundish nuclei. And, you've learned already that the epidermal layer is epithelial in origin, and you know that it's a stratified squamous epithelium. So what the heck? Why do we have cuboidal cells here at the bottom? Well, that's because as the cells grow and mature, they become more and more squamous in shape. But they begin their lives as cuboidal or even sometimes columnar cells. And they are stem cells. So these are cells that divide repeatedly. And they get their nourishment from the blood supply that comes through the dermal layers. And they're attached to those basement membranes by what's called a hemidesmosome. It's like a half desmosome. Remember that very flexible but super strong connection that holds cells together. And they grow and divide by a cellular division process called mitosis. And mitosis is just that, we've already talked about it, it's the prophase, metaphase, anaphase, telophase, those processes. So, and depending on where the skin is, these cells may divide as frequently as one time every day, once a day. And when they divide, the cell that's attached to, the daughter cell that's attached to the basement membrane remains a stem cell, but the other cell, the one that's closer to the apical surface of the tissue, is now fully differentiated. It will not divide again, and will be pushed upward toward the apical surface as new cells are produced here at the bottom. So here's the basement membrane, here's a cell. It just divided, and so its next job is to grow. It could become even columnar looking. Then it goes through the processes of mitosis and divides, and now we have two cells. So once again, the basement cell will grow. It's got its cell above, the first daughter cell that we talked about. Eventually that taller cell will divide again, and so now that cell that was the product of the first division is going to be one cell removed from the basement membrane. And so that's how these tissues grow over time. So here's our two cells. We can even label them one. Here's two. Now the cell divides again, and there's three cells above our original stem cell. So they're fully differentiated once they divide off, and they keep getting pushed upward toward the apical surface as the new cells at the basement membrane are produced. So there's the stratum Visalli. So now let's look at the stratum spinosum. These are this is a micrograph of stratum spinosum cells, and of course this cell layer down here, that would be the stratum Visalli. And so every cell from here until about the point where it gets really good and dark are stratum spinosum cells. So they're pushed upward out of the stratum Visalli, and it's multiple cells thick, so it could be fairly thick. And as the cells get closer and closer toward the apical surface, they begin to flatten, and they synthesize and store lots of keratin. They're also adding melanin packets. Those melanosomes are being added to the cell's cytoplasm, and more desmosomes are added so that the cells become very connected side to side, especially. And so they keep getting pushed up and pushed up until they get so much keratin in them and enough, and it's, I said melanin, so they're getting more melanin, but it's primarily the keratin that makes them look grainy. So I apologize for that misspeaking earlier. All right, so here is a microscopic view of the stratum granulosum, and this inset here, this square, I'll just outline it here in red. These are cells from that same region. I don't know that they're exactly from, yeah, because they don't look quite the same. But if you were to look in really close at those cells, here's what you would see. So these are the cells. It's kind of starting to get flat. There, this one's kind of getting pushed around. This one looks nice and flat here. But you notice all that graininess in there. All those little granules would be the keratin packets, or the keratin that's building up in the cytoplasm. So this stratum granulosum, these cells are usually about 3 to 5 cell layers thick, and at the most superficial side here of the stratum granulosum, the cells begin to lose their organelles and die. And they do this because they've gotten so far from the supply of nutrients and oxygen and the chance to get rid of wastes, because they've gotten so far from that basement membrane and the dermal blood vessels down below, and because they've become so packed with keratin that there's just eventually no more room for the organelles. So by the time these cells migrate up into the last of the layers, the stratum lucidum, and then on up into the stratum corneum, these cells are generally dead. Once again, so now we're at the stratum lucidum, and again, this is a cell layer only found in thick skin. But again, it's also not the reason that thick skin is so thick. It's because the stratum corneum is especially thick in thick skin. So these are cells that have been pushed out of the stratum granulosum, and it's usually just a few cell layers thick. And these cells are translucent. If something is lucid or lucent, it's clear-ish, and so lucidum is feeds back to that term there. Okay, so now we get to the last layer, the most superficial layer, which is the stratum corneum. The stratum corneum is cells that have been pushed up out of either the stratum lucidum or the stratum granulosum, and it can be 20 to 30 layers of cells thick. So again, in thick skin, this is that especially thick layer. The cells have been fully keratinized, so they're stuffed full of keratin. They're dead, and all the organelles have been lost. And it's up here at this apical surface. You can even see some being brushed away here. It's starting to flake away. The cells at the apical surface are lost, and so we have to balance new production from the basement membrane, from that layer of stratum basale, with the loss that occurs up at the apical surface. And in our skin, the apical surface is tough, it's dry, and it's waterproof. Okay, so there we are. So, as I was saying, cell production at the stratum basale is balanced by the cell loss at the apical surface. And so here's some interesting facts about skin. Nearly 40 pounds of skin cells are shed by a person each year. It takes about 2 weeks for a cell to migrate from the stratum basale up to the stratum corneum. Then it's about another 2 weeks or so for that cell to be shed from the stratum corneum there at the apical surface. And anywhere that we press or rub the skin repeatedly, the stratum basale responds to that. It notices that extra pressure, and it increases production down at the bottom. And so that causes the development of calluses. So here's a callus on the ball of a foot. So you can see it's thickened. It's a little yellowish colored and scaly, dry. Or it could become what's called a corn. So here's a corn on the bottom of the foot, and here's another corn on the side of a toe. These are projections of especially thick stratum corneum layers that can actually rub and be painful. So calluses generally aren't painful, but corns can certainly be painful. All right, so we've talked now about the epidermis. Now it's time to turn our attention to that deeper layer of the cutaneous membrane, and that is the dermis. So the dermis is deep to the epidermis, and it binds the epidermis to the underlying tissues. And it's the dermal layer that corresponds to the leather that we take from animal hides. So if we think about cow leather, it's the thick dermal tissues that we tan to produce leather. And the dermal layer occurs in two sublayers. There's the papillary layer. So these little projections here, the bumps, they're referred to as the dermal papillae. So the papillary layer is this layer directly underneath the basement membrane. It's usually fairly narrow, and it's composed of areolar tissue. And then deep to the papillary layer is the reticular layer. So from here downward would be reticular tissue, and it's a dense, irregular connective tissue. So that means that the fibers, the collagenous and elastic fibers, they run in all sorts of directions. There's not a grain to the fibers. And a gel-like ground substance is what makes up that papillary layer. All right, so let's take a moment now to look at those dermal papillae. So here are some very obvious dermal papillae right here. And so we see that the boundary between the epidermal layers and the dermal layers are not nice and flat. They're very uneven, with these dermal papillae that push or dome upward into the epidermis layer. What's the value of that? You should be thinking, what is it when we see those wavy margins between two different structures? Well, it's usually about increasing surface area. And sure enough, these papillary or the dermal papillae, they allow for an increase in that surface area that's in contact between the dermis and the epidermis. So why would that be valuable? Think a little bit about what the characteristics of the epidermis are. The epidermis is non-vascular, while the dermis is highly vascularized. So why would it be important to increase that surface area? Well, hopefully what you thought about was we got to get nutrients and oxygen into the epidermal layers because there's no blood vessels there. And so the more surface area that we have between the dermis and the epidermis, well, then the easier it is to get that oxygen or nutrients up into the epidermis and get the wastes delivered down to the dermis. And the dermal papillae, especially in thick skin at the hands and the soles, so it shows up as those dermal papillae show up as the ridges of our fingerprints. And if you were to look at your toes, you'd notice you have toe prints as well. So it's also got a lot of these fingerprint ridges at the epidermal apical surface. And apparently the value of having fingerprints is that it allows for better grip between the hands and anything that we're trying to grab or pick up. All right, so there are other tissues found in the dermal layer in the dermis of the skin. There are smooth muscle cells, and so we'll take a look at those when we look at a hair follicle. We'll see where the bundle of smooth muscle fibers are. There is certainly a rich supply of blood and lymphatic vessels in the dermis. And then we have lots of nerve fibers that are busy collecting sensory information. There are Pacinian corpuscles. These detect heavy pressure. So imagine your sweetie giving you a nice deep tissue back massage. Well, that would be your Pacinian corpuscles that notice that. Then there's the Meissner's corpuscles. These detect light touch. So imagine somebody taking a feather and just gently tickling your skin surface. Well, that would be your Meissner's corpuscles that notice it. So here's a Meissner's corpuscle. There would be a nerve cell that terminates right here, and it can pick up that light touch. While these Pacinian corpuscles, they are deeper in the dermal layers. There's another Pacinian corpuscle. So we got 3 of them right there in this one area, and it takes heavier pressure to activate them. And then finally, there are also just free nerve endings that are responsible for noticing warmth and cool temperatures, and then finally pain. So if we get squeezed really hard or the skin gets crushed or ripped, then pain receptors go off. And if we encounter something that's super hot or super cold, then that will also trigger pain reception. And so we find these dermal tissues, and then all of the accessory structures of the skin, they all originate deep down in the dermis as well. And so we'll be looking, in our next unit, we'll take a look at these accessory structures. We'll try to make some sense of it. Okay, so just to review, 2 types of skin. There's thick skin and thin skin. And there are 4 or 5 layers of skin keratinocyte types. And from the bottom up, that's the stratum Visalli, the stratum spinosum, the stratum granulosum. If it's thick skin, then we see a very obvious stratum lucidum. And then finally, the most superficial layer is the stratum corneum. And then there are a number of other tissues involved. There's the dermal tissue beneath the epidermis that has a lot of the blood supply that brings nutrients into those epidermal cells. And then finally we see in skin, in this dermal layer, we see muscle cells, the source of the blood, and then the larger blood vessels, and also lymphatic vessels to help carry fluid away from the skin. And then specific sensory organs such as the Pacinian corpuscle, the Meissner's corpuscles, and then other free nerve endings. All right, so we are done with this video, so get fired up for the next one, and I'll see you then.